So after doing all this, we have a UART wrapper and we have the corresponding VHDL files, which we can now edit, and we have included all the libraries which are required by the UART. So the changes which we are going to make is because right now what is happening is the the microblaze is writing into the transmission FIFO this UART TX underscore I, and then the UART is reading from this FIFO. So what we want to happen is that the microblaze should write to the FIFO, and then we should read from the FIFO through the PCI and not from the UART. So the things that we need to do is this is the structure of the FIFO which is used by the UART. Originally the read signal for the FIFO is generated by the UART, and the output signals, that is the data out signal and the FIFO underscore empty signal, are given from the transmission FIFO back to the UART. So what we want to do is that the read signal should be generated by a replication, and it should be the signal should be transmitted should be generated by us and not by the UART. Similarly, the data out signal should not go to the UART but to some signal which we ourselves have created and which we can use to interact with the PCI. Similarly for the FIFO underscore empty. To summarize this, basically originally we are reading from the UART FIFO by or we can write we are originally reading from the UART FIFO by a UART, but now we want to read from the UART FIFO via PCIe. So the read signal for the UART transmission will not be generated in the UART Lite VHDL file, but we will supply this signal from a state machine whenever a read request comes from the user application. Later we'll describe the structure of this state machine. So to receive this read signal from the state machine, we will be creating an input port called fread to receive this signal from the state machine. Next, to forward the output to the PCI and not to the UART, we will create an output port called alpha data and redirect this data underscore out signal from the transmission FIFO onto that signal, and then we'll use this alpha data output port to interact with the PCI. Further, there is this FIFO underscore empty signal. We will create our own output port called empty and redirect this signal to this port, and that's what we are going to do in the next few minutes. So basically now we'll be making changes in this transmission FIFO file which we have opened. This file may be read only, so you might have to change the settings of the file. Now we'll be adding some output signals. This is the data output of the FIFO which we will be using in the PCI. Next we need a fread signal, which is basically an input signal. It is a bit. We also have an empty signal which is an output signal. So we have modified the structure of the transmission FIFO, and you need to make some changes here also. So data out is now alpha data. The FIFO empty is empty, and FIFO read is fread. So now you have to make these changes in the higher level VHDL files, which are basically using this transmission FIFO. First you have to change this UART light core. You have to add those 3 signals which have already been added. This is the project which we are working on, and so here in this VHDL file, the UART light core, the 3 signals have not been added, and we'll add them now. But as you can see, this file is read-only file, so we have to modify it a bit. You can change the properties. Now we can write in this file. So basically we need to include the 3 signals which we had declared in the transmission FIFO. So we can just copy them and paste them here. And at the place where the transmission FIFO is declared or instantiated in the UART light core, we have to make some changes there also. So this is the declaration of the transmission FIFO. So we just need to write that alpha data is alpha data f read is f read and empty is empty. Basically these signals, alpha data here and alpha data here, they correspond to different VHDL files. Now we have to make similar changes in this. This is again a read-only file. We have to make some changes. So now we'll add similar signals to this. And at the place where the and now at the place where the UART light core has been instantiated in this XPS UART light VHDL file, we have to make some changes. We have to find it first. Yeah, this is the instantiation, and we'll add the similar thing, alpha data and we can basically copy it. Now we can change this 0 down to C data bits -1 to 7 down to 0, because that's what we will be using. This we could have done this earlier. We have to make similar changes in the RS-232 wrapper, and so we have to make similar changes in the wrapper also. We just have to add the 3 signals which we can copy from here. But in the wrapper VHDL file, the XPS UART light is declared as a component, so you have to make the changes here also. So the 3 signals have to be declared twice, they have to be written down twice, and in the port map of the XPS UART light we have to make the old change where we declare alpha data, where we tell that alpha data is equal to alpha data. These are in different VHDL files. So now we have made changes in the RS-232 wrapper also. Now finally we have to make some changes in the system VHDL file. So we have to add some signals to the system.VHDL file. So now we'll make some similar changes to the system VHDL file, and we just have to declare those 3 signals once again, which we can copy from the changes we made earlier. But in this case these are signals and not ports. And then we have to change the component RS-232 in the system. And now we'll change the port map of the RS-232. This is similar to what we have done earlier. Now you also have to change the component declaration of the RS-232. This is the same thing. And now let's try to synthesize the system VHDL file, and let's see if it works.
When we are to stop the
So I think it is working now.